Today we're going to be talking about oxidation number and states. If you have a pure element, the oxidation state is always 0. Fluorine has an oxidation state of -1 when it's in a compound. Oxygen has an oxidation state of -2 unless it's bonded with fluorine. Hydrogen has 2 values. Which could either be +1 or -1. Hydrogen has an oxidation state +1 when bonded to a nonmetal, and when bonded to a metal, it has an oxidation state of -1. Now, let's do a sample problem. Let's do the example H2S. As you can see, sulfur has a partial negative charge, and hydrogen has a partial positive charge. Since hydrogen is bonded to a nonmetal, we know that it will have an oxidation state of +1. Now, let's look at sulfur. Alright, so we have 2 hydrogen. We're going to solve for sulfur. Alright, so we're going to do 2. Put the 1 in here since it is a plus. I'm just going to use x as our variable so it's easier. We're going to equal that to 0. Alright, so we're going to subtract 2 from both sides. And we would get x equals -2. So now we know our sulfur has an oxidation state of -2. It shows it has this natural charge according to the periodic table of -2. Now we're going to talk about a little bit more about polyatomic ions, kind of like we did. So let's do another problem. Let's look at oxygen difluoride. Alright, so here oxygen has a slightly positive charge because fluorine is more electronegative. So we can't replace oxygen with -2. Instead, every time we see fluorine in a compound, it would be -1. So that means, yeah. Alright, so we have oxygen, which is equal to 2 fluorine, which we're going to equal to 0. Alright, so this would be x. We're going to substitute the fluorine for -1, and then we're going to equal that still to 0. Alright, so you're going to get x